Hi, this is Ian from Convex, and I want to show you today a little bit about writing good types while you're writing libraries and using TypeScript to your advantage so that people who are using your functions will get great autocomplete and they'll see exactly what they need to put in. And even you can limit what they put in so that they can only put in the right values. To explain it a little bit, I'm going to show you something I've been doing recently. There's a package called Convex helpers that I've been working on, which is just a collection of functions and utilities for using Convex to help you be more effective and just make it really easy to use Convex. For those of you who don't know, Convex is a backend as a service. It includes a database, functions, everything you need to run a full stack app, and it's particularly good at real time and with React, subscriptions, cache invalidation, all kind of out of the box without you having to configure anything. But we'll see some of that as we go. We'll jump right in. So let's define a schema that we're going to be talking about here. We'll add an index on the user ID. And you'll see here, this is the first example where we get to see when types kind of help you autocomplete. Instead of this just being a string, it actually tells you it has to be one of the fields in your document. So here it's either a creation time, which is a built-in field, a text, or user ID. So we'll pick user ID. So what we've done is made two tables. One table has comments, which have text and a reference to a user, and then users themselves just have a name. We can look over here in the dashboard. I've created just one user with the name Ian. We could maybe create another one, test user, and we can copy that ID, go over to the comments table. There's a few comments here from the Ian user, but we can put in that user ID that we copied from the other page. Another comment. Cool. So we have some documents in our table, and we have our schema. To sync this schema and sync the functions as we're writing them, I'm going to run npx convex dev. This will deploy our functions. Great. And the schema is there. Okay, so let's say we're trying to write a function like get all the comments for my user, and now we're in the body of the function. This is a query, and in Convex, queries run in the server. We're in the Convex directory. Everything in the Convex directory will run on the server, and it will query the database. So this is only able to read from the database. It isn't able to mutate it, and it isn't able to do any side effects, so we can write kind of deterministic code in here. Let's write a query. So usually you'd have to write a long database expression, and you'd have to remember how to use the indexes and all that. Convex helpers gives you a few utilities to do one-to-one relationships, one-to-many relationships, and many-to-many relationships. One such helper is called getManyFrom. So that's it's kind of a one-to-many or a many-to-many relationship where you're trying to get documents from one table based on a key from somewhere else. So in this case, we want to fetch documents from the comments table based on this user ID key. So there's a one-to-many relationship between users and comments. Each comment just has one user. A user may have 0 or more comments. So this getManyFrom, what types does it ask for? It asks for a database reference, so that's a DB. Our context has a database object in it, so ctx.db is one such database handle. And then we'll see the next argument. And so this is where, in this case, there wasn't any other table that I could have been fetching something from, because the users table doesn't have an index by which I could do a one-to-many lookup. It's only in the comments table where I'm actually able to fetch a bunch of comments based on an index, in this case the index of the user ID. So this is what this is what I'm kind of talking about when I'm saying that the types that you can provide can kind of force your user into the right path. And we're going to actually look in this video at how this is accomplished. So what's the next argument? This is a field. You'll notice that the description here on the field is argument specific. So when you're back at the table, it says the table to fetch the document from. The next argument is the field on that table that should match the specified value. In this case, it only lets me select user ID. And then the last one is the value. The value to look up the user, the document by, usually an ID. In this case, it's telling me it's an ID into the users table. So this is great because it means that I don't have to remember what all the parameters are. It kind of like gets to auto-complete my way to success here. So what we're going to do is look at what this is doing, how it's doing it, and how we can extend it to get kind of different behavior depending upon kind of how we want the ergonomics to work, and talk a little bit about the trade-offs when you're kind of making functions like this. So I've pulled up over here the Convex helpers repo. This is for the actual package that I publish. You'll see it's in the packages Convex helpers folder within the overall Convex helpers repo, which is open source, available to you to extend, put in a PR if you think of something that you'd like to have included there. And here we're going to look at the get many from function. I've actually used a cool little trick of linking this repo or in this folder to this project. So as I edit types here, the types will actually show up even though this is just including Convex helpers as a dependency in its npm package. You can see package.json, lists, convex helpers. This is pointing at 1.10, but actually this is running some custom code over here. The way that I did that is doing npm link convex helpers. And in order for that to work, I also have to run npm link in the convex helpers directory, and that tells npm to just set up some symlinks so that the files, as you're editing them, kind of live update in the referencing directory. So we have our function, and it's returning the comments, and you'll see that the comment types actually come back telling you what the types that it fetched from the database are. So it said, hey, I'm looking in the comments table. I'm going to look up things by user ID, and everything that matches this user ID is going to be returned. So it's going to return these comment documents, and that is the type that's here. It's an array of comment documents. ID and creation time are added by Convex. Text and user ID are specified in the schema. So I could return comments, and then I can run this. It'll sync up to Convex, and here I'll do get user comments, and I'll pass in user ID. Great. There's that comment that we passed in, and if I grab the user ID for the other user and I pass it in, it'll show comment 123. Cool thing about Convex, it's automatically reactive. This is not just the case in the Convex dashboard, but also in your web app. I'm changing comment 3 to comment X, and you'll see down here when I commit that, comment X is right there. So I'll switch that back to 3, and we're off to the races. Okay, and maybe I'll turn this comment into just the text. So that'll sync up, and then over here you'll see comment 123 is coming back from the query. Cool. So let's look at how some of this gets done. So the first thing that we'll see, and I'll clear this out of the way so we have one more screen, the get many from function. So it takes in 3 type parameters, and in TypeScript, the way that you make a function generic for more than one specific type is to have type parameters. For instance, I could have a version of this function that isn't generic at all, that only works when the table is exactly one type of table, and only when the field is exactly one field, or only when the field is a string, well, only when the table is a string. When you have those types of types, you don't need to have it generic, but then when you're in your function, you have the arguments just as, as a string. And when you do db.query with just a string, it doesn't tell that function what specific table it is, and so it can't infer the types from then on. And so by being more specific, you kind of give the TypeScript environment more information to work with. And so you'll see that because of these types, I don't have to use any casting or doing as or doing any's. This is just a regular JavaScript, except for all of this kind of type parameterization. So let's take a look at what some of these type parameters are. And if that doesn't all make sense now, don't worry, we'll kind of like see it, and we'll just kind of get some experience working with these, and it becomes kind of more familiar the more you're working with it. So it takes 3 type parameters: data model, and that's the data model that kind of describes your data in your tables. And the table name, in this case, this will be the comments table, and the field, this is user ID in our example. And so it takes 4 actual parameters, so 4 runtime parameters. This is the DB that we saw, the table, the field, and the value. And a cool thing that we're doing here is the DB that you pass in first is of type generic database reader of a data model. So when I pass in, before I pass in the ctx.db, this doesn't really know what type the data model is. So here it's just a generic data model type. But when you do ctx.db as your first parameter, all of a sudden it's saying, hey, this is a database reader with a users table and comments table and some other things. And that actually adds the first type parameter kind of implicitly. So over here, it takes in these 3 type parameters, but I actually haven't given this any type parameters. It's just taking normal parameters. And we'll see it again in a second what we're kind of doing here. So the second argument is a table. And so this is a table name. And this is not just a regular table name. This is actually a table name that has to extend this tables with lookups. And this type is a kind of fancy type that I made that says, hey, only limit it to the tables that actually have indexes. And in this case, the index is a lookup, is the kind of parlance I'm using here. So it says the second parameter is only tables that have lookups. In this case, it's just the comments table. I could go over here and add an index on name and come back here, and it would give me 2 options. It would give me comments or users. And if I picked users, the next argument it would ask is for the name, because that's the only thing I have an index on. But in this case, it's just comments. You'll notice TypeScript kind of infers the types without me even saving these files. These types aren't from code generation. They are inferred kind of through the types that are defined live. So that's a really cool kind of fast feedback mechanism of Convex. There are generated files, which is where the types kind of are derived from, but they happen kind of live. It doesn't require code genning in order to kind of like propagate the types. Okay, so second parameter, table name. And so now that I've passed in the table name, that also kind of like defines what is the concrete table that we're actually dealing with. And so now we know the data model and the table name just by providing regular arguments. And the nice thing about that is that here the next argument field is actually another kind of fancy type that I made, which is hey, what are the paths that are on a table where the field name actually matches the name of the index. So in the scheme over here, I kind of glazed over it, but the index is named the same as the first field that's in it. So this is a pattern that I end up using and that I think is somewhat common, where when this is just the name of the index, I could name it anything I want. Some people do by underscore then the field name. But when the field is exactly the same, then it lets me do this nice little helper where I don't actually have to specify both the index name and the field name. So this type tells me what are all the fields where the field matches the first path on the index. So an index can have many paths, and this tells me when the first one matches the actual field. The field name matches the index name. A lot of words, but what that limits it to is it doesn't let me pass in just any field on comments. It only lets me pass in user ID. Now, if I had defined another index on text, then it would let me pass in either text or user ID. And the third argument is the type that is there. So here we have passed in the table name, which set this parameter. We passed in the field, which set this parameter. And then the last field is this fancy type that actually includes all three parameters that we've had so far. So the data model, the table name, and the field. And this grabs the type of the first path in the index that is named the same as the field that we passed in. So in this case, it says, okay, we're using this data model, we're using this table name, we're using this field, which matches this index name, and then this is the type of the data that is at this field path. And field path is just kind of like the field name, but if there was like a nested field, it would have the kind of dot separated syntax in order to kind of traverse to get to that field. So field path is user ID. The type of user ID is an ID to the users table. Okay, so why is this? We just kind of saw this twice in a row. Why am I actually pointing this out? One thing to kind of keep in know, and this is maybe the first trick, is that when you have parameters that are going to set your type parameters, it's actually really useful to pick the order in which the parameters are given. So if I had actually put db not as the first argument, but as the second argument, then when the user's writing out the query, their first kind of argument here, it's going to ask me for the table, but it's not going to give me any hints about this because it doesn't know what the data model is. And so I'm just going to have to kind of guess, and there's going to be no autocomplete, and I'm going to have to, maybe if I wrote comment instead of comments, then the next one is going to ask me for the database, so then I do ctx.db, and then now it's telling me never. It's like, why is the field never? I don't really understand. Oh, it turns out that this is actually comments, and now I get some more type hints. Okay, so yeah, just by switching kind of the order that you import things, like obviously the worst order here would have been to ask for the value first, and then the field, and then the table, and then the DB, because at each step, the one relied on the previous, like the one type relies on the previous type. And kind of just for completeness here, let's go back to how it was. Okay, so we have this function, and it just another thing to note, when you're writing these functions, you can just specify all the type parameters. So without writing any of this, I could have put in these type parameters of data model. In this case, it's imported from the kind of like generated file, and this tells me what my concrete data model is. And this is just, this is actually just a type. It's not an actual runtime thing. Okay, data model. The next one, let's see if it gives me any hints. There we go. Table name. So I could say comments. And then the last parameter is the field. So user ID. Okay, so then when I call it, it's gonna ask me for comments and user ID. Now, if I change this to text, then as I kind of go through this, it'll say comments, and here where it used to offer me user ID or text, it now just says text. You can explicitly specify these sorts of parameters But when you have your arguments kind of help you out, and when you define your arguments in a way such that they can be figured out, and you figure out what the right parameterization is, you can get the autocomplete experience without having the user write any types. One thing that I love trying to use as a North Star is like when the user is actually writing their code, you really want to avoid them having to use explicit like TypeScript typing as much as possible. If you can kind of have the function arguments and the values that they're passing around kind of like kind of give them the types automatically, kind of the better off people are. Like this actually could just be a .js file. Like there are no actual types here except for that data model, which I just deleted. There's no explicit typing, and yet we get all of the benefits of type completion and kind of type hints. Okay, so to summarize, for this first little step, parameter ordering really helps when you're trying to design these things. Great.